but we don't know the opposite side. We know 60 for this length, but we don't know the opposite angle. We know 75 for this side length, but we don't know the opposite angle. So what will happen is if you write out the sine law, start plugging in those three numbers, you'll find that each of your ratios only has one of the two numbers that we're looking for. There is no ratio that has both numbers. Because once that happens, then it's awesome. But that's not happening, so we're stuck. So what I want to do is we'll go back and sort of try to derive on how we can actually calculate for A now. So I want to focus us on the red triangle. So we have a red triangle, we have side length 60, angle 64. We have a side length called X now. We have a side length called H, which is the thing we drew down. So what can we see about this red triangle? What are some of the things that we see with this red triangle? Jenny?
Marshall, question.
Sure.
The red marking next to the X, it says like something X.
75 minus X.
Oh.
Because if I said that this length is X, then the length of this other triangle is 75 minus X. Okay? Adrian? What's one of the things we can say about the triangle on the left, the red? Okay.
Something to say?
Sorry?
I don't know.
Anything.
Oh.
Do you know something about this triangle we could do with on the left?
So you're given two angles, you can find a third angle and then do that.
Sure, so this angle here would be 26. Right? What's a shot? Maybe we could do something with a 26. Anything else? You can see this triangle on the left?
Is the line exactly?
So it's not exactly in the middle. We just know it's straight down from C though. It comes down at a right angle to the other side line. So it's not exactly in the middle. We can't say that for sure. Anything else to say about that triangle left? Think of your trig ratios. Think of your trig ratios. Do you remember what our trig ratios are?
Sine.
Sorry, Adrian?
I don't think you can use sine.
Sine what?
Sine ratio.
So sine of,
26. Doing so much math.
well, you know what? Let's work with the stuff that we're known. Okay. 64 is what?
Opposite of red line.
So in this case, what's the opposite of 64? H. The hypotenuse. So what's the hypotenuse over here? 60. So can I sort of figure out what H is? Yeah, what's H?
H equals sine of 64 degrees over 60.
Close.
Or
Multiply both sides by 60. So we isolate for H. So H is really 60 times the sine of 64. Anything else that we can see with the triangle on the left? So let me give you a hint. The title of this unit is called Cosine Law. I think Demetrius already alluded to. So is there anything you can see from the left side, the left triangle now? That might be related to cosine. Look at the left side triangle. We're given an angle. What can we work with? Katie, help me out here.
wait, with cosine, did you just write cosine 64?
Sure. What's the cosine of 64? What's that in this case? So look at our triangle. So what's cosine? Cosine is so ka. So adjacent over hypotenuse. So what's the adjacent side?
Wait, adjacent over hypotenuse?
Yeah.
Calm down.
So what's the adjacent side to 64?
No, not even.
I know you weren't talking to me.
No.
It's fine.
64.
So what's the adjacent side to 64?
H.
No, that's the opposite side. Right, we're talking about to 64
Oh, okay.
here.
No, X.
So it's x, and what's the hypotenuse of this triangle?
60.
60. Okay. So what can we determine the value of x to be? We can isolate for x. So same thing we did with the sine. We're going to multiply both sides by 60. So we get x is equal to 60 times the cos of 64. Okay. So those are two things that we kind of see with this triangle on the left. I see one other thing in the red triangle. So we made two observations. What's another observation that we could make? You could have made this last year, or you could have made this even before we started trigonometry. What's the relationship that we see in that triangle? What can we see in that triangle on the left?
What does it say? What is C? The angle C? What does it say?
It's not angle C. We just know part of angle C has 26 because
Okay.
we're looking at the left triangle, the red triangle. What else can we see about that red triangle?
Wait, did we find this?
It's all right.
Oh, wait, what on the left?
The one on the left, the red triangle.
Yeah, we're looking at the angle for C.
Well,
Well, this applies to the right triangle.
okay, but we're focusing on the left. Go ahead.
We can figure out the adjacent side of the right triangle.
Okay, so
Where would you?
I want us to put our brains away. We're so tempted to solve for things. I'm just looking for observations. So yes, we can have an answer for h, we can have an answer for x. We take those numbers. I'm looking for another relationship in a triangle here. Before trig. Think back to the days before trig, was really before March break. Almost right. 90-degree angle. What do we know about the sides? 90-degree triangle. What can we say about the sides?
Pythagorean.
Pythagorean theorem, right? We can look at the right triangle left. Do Pythagorean. So what is that here?
This is too confusing.
That's what I want you to observe, Daniel. Sorry?
X is A.
So x squared
H squared
plus h squared.
equals, what do we call it? B squared.
Well, we actually have a value there.
Oh, where?
What's the length of that side?
Oh, 60.
So it's equal to 60 squared. Right? Pythagorean theorem, x squared plus h squared is equal to 60 squared. Okay, we saw that, Pythagorean theorem? So three sort of observations we made a triangle on the left. Now let's look at the triangle on the right. Look at this green triangle. What can we say about this green triangle? What kind of observations or properties can we see from this green triangle on the right? Well, I think there's no angles. We have no angles. But we're sort of given side lengths, right? We're given h, a, and 75 minus x. So let's apply the Pythagorean theorem to this. So what's the Pythagorean theorem on the right triangle? I'll start it off. A squared is equal to. Okay, but in terms of context of here,
H squared minus 75.
h squared plus
Oh.
75 minus x. So that's the side length, right? 75 minus x, we want to square that. So question, don't have to write this in your notes unless you want to. Does everyone remember how we expand that? How do we expand that quickly? What's a shortcut to expanding that? Hannah?
I just have a question.
Sure.
Isn't it H squared minus 75?
Missing it. Sorry?
Isn't it H squared minus 75?
No, what's the Pythagorean theorem? Is a squared? So one side squared plus the other side squared. Right? So one side is h, so that's h squared, plus the other side is 75 minus x, all that squared. So that's how we got that. Okay?
Wait, but if you were to put A, B, C, which one would be which? Just because
Don't think of a, b, c,
No.
right? So all Pythagorean theorem is the hypotenuse squared. So which was the hypotenuse? A. So it's a squared is equal to the square of the other two sides added together. Right? So it's h squared, which is this side, and then 75 minus x, that's a value. That's why it has to be quantity squared, whatever that value is, 75 minus x. Okay? So a little bit of review, back to unit 5. X minus 3 quantity squared. How do I quickly expand that? Daniel?
X squared minus 6x plus 9.
How'd you get that so fast? You remember what you did, the steps?
Yeah. If you expand it out, you get. I mean, how did I see it? Like I saw
Did you
two
expand?
brackets.
Did you
Yeah.
x minus 3 times x minus 3? Does everyone remember the shortcut though?
What?
Yeah, but does everyone remember the shortcut?
Square root. It's the square of x.
You do want.
Yeah, so you take this, take the first one, we square it, right? You want to add two more?
Yeah, and then you do the second number, so 3,
Right?
and then times 2,
So we get that squared, and that's a plus.
and then minus 3 times x.
Good, we take the minus sign down, so it's minus 3, actually,
Or is it
minus 2 times
times?
x times 3, right? It's minus 2 times each of these multiplied together.
Yeah.
I just did it in the,
Yeah.
so I just left to right. So does everyone remember that? So basically that comes up to what Daniel said, that's equal to x squared minus 6x plus 9. But does everybody sort of remember this part?
But where
Remember the
did you
shortcut?
get x minus 3 from?
I just made that up.
Oh,
I
okay.
just want us to refresh our memories on how we do something quantity squared. So we go back. I'm going to do that to this part now, 75 minus x quantity squared. So here we get a squared equal to h squared plus, now I want to expand this part out. So I get 75 quantity squared what do I get in the middle? Minus 2 times 75 times x, then plus x squared. Okay, so all I did was I took a 75 minus x quantity squared and I expanded it. Well, which is that the one part that's being squared, it's a binomial actually. So we expanded it out. Okay, everybody clear with that one step? Now I'm going to shuffle things around a little bit. So a squared is equal to h squared plus x squared plus 75 quantity squared minus 2 times 75 times x. Okay? Okay, so all we did was now we replaced the a squared plus x squared with 60 squared. Plus 75 quantity squared or squared minus 2 times 75 times x.
Can't you just simplify the end? Can't you just do?
I could, but I want to show something here. Is there something we do the x? do we see something on the left-hand side of the left triangle where x was equal to?
60.
Over here?
64.
Yeah. So x is really equal to 60 times the cos of 64. So in the end, I can just get a squared is equal to 60 squared plus 75 squared minus 2 times 75 times 60 times the cos of 64.
Why do you?
Because this part here,
I had the H turn to 60.
this part here, that's where x was equal, that's equal to x.
Where'd you get?
I replaced x with what we said it was here. X is equal to 60 times the cos of 64.
How did the H turn to 60 but having also the sine of 64?
How did the h?
Yeah.
I haven't done anything with this yet because I don't really need it. H just stayed as h.
So where did 60 turn?
I got rid of h because h squared plus x squared was equal to 60 squared.
Oh. I was just
Okay. So we take out our calculators, we can plug in a squared is equal to 60 squared is 3600. 75 squared?
Do you have the plus x at the end?
No, I'm just saying the thing that I did in red that was equal to x, that's what we replaced it with.
But then what about the plus x squared?
I don't have a plus x squared. I got a squared plus x squared, I got rid of that with the 60 squared.
Oh.
I got rid of two variables with one number, which is pretty cool. 75 squared, calculator,
5,625.
5,675?
25.
And then what's 2 times 75 times 60 times the cos of 64? 3,925?
45.
45? 0.34. If I add those two numbers and subtract, what do I get?
Oh no, I subtracted. No.
5,037.9.66.
Oh,
So how do I get for a?
that's good.
So that's a squared. So I take the square root of both sides. So what's a? 72 point what?
What does it say after a squared equals 3600 plus? Wait, is this all just defined? Never mind.
Yeah.
so fast.
Wait, then how do we find
That is
Just
a.
found it.
what about h?
Sorry?
Do we have to find h now? No. That's
No.
just like a line quick.
H just helps us get to what a will
So we
be.
have to do all that just to find a silent?
Isn't that pretty tough?
It sucks.
Then once again, shortcut.
That's a long
How many
question.
marks would this question be, like, to
If
my
I did it like this and you didn't know
Exam.
anything
Maybe
better,
like 7 marks.
that would be like 4 or 5 marks.
What?
7 more.
For all that
We're gonna
work.
try like this Easter color crayon thing.
Yeah, you should.
Easter color?
Yeah.
It's an Easter color.
Wait, that's
Okay.
disgusting.
So go back
Yellow.
as you wrote your notes.
Yeah.
Right, Daniel? As you wrote your notes.
I'll just write this by right, I'm not listening to you. You wanna write this and then go back.
Then why don't we just take the video afterwards and then let's see notes next class.
Oh.
Then you can take the video afterwards and I want to see notes for next class.
Oh, what?
So I want you to go back to that equation that we had and highlight it. Because yes, it is a pain in the tush to do this all the time when we're given two side lengths and the angle in between and do all this math so that we can solve for the triangle. So what we're looking for is a pattern. What can we recognize? So in here, with the big blue box, this equation, we can sort of simplify this or map this back to the letters in our triangle. So here we got a squared is equal to, what's 60? What does that map to in our triangle? 60 maps to this side, of the triangle, which is what letter?
B.
B.
I know.
So it's just b squared plus,
Wait, why is it
because we're looking at the 60, we're mapping back to the triangle. What's the 60? It was the side length, right? Which is b. What about 75? What was 75?
The C.
Yeah, c, which is the bottom length. So this was c. So plus c squared minus 2 times, what's 75?
C.
75 was c again. 60? B. And finally, what's 64? What's 64? Which is A.
Where'd you get the 2C?
We had over here 2 times 75. So 75 was C. 60 was B. And then we had cos of 64, but 64 was really A. So we go back and look at the original triangle. This is what we actually call the cosine law. Okay, so we draw the triangle without the numbers. We just label our triangle a standard way, ABC. So the cosine law tells us what we just sort of discovered. A squared is equal to B squared plus C squared minus 2 times B times C times the cos of A. So 2BC times the cos of A. Big. So what you rather use? This one or the sine law?
Yeah. Sign.
Wait, what?
You having some? You okay?
No, I'm fine.
I'm so
But when we do this,
I'm almost against showing you this next two because it's really the same thing, just sort of repeating ourselves. You can redo all this. You still get the formulas of B squared is equal to A squared plus C squared minus 2 times AC times the cos of B. Or we could also say C squared, so depending what side length that you're looking for, C squared is equal to A squared plus B squared minus 2 times AB times the cos of C. Now let me try to summarize this because honestly I hate formulas with letters in them. Because most of the time you're trying to map letters, if the triangle isn't drawn the way that it was before, you memorize the letters, you get mixed up. Essentially what it's saying is that if you're given two sides of a triangle and an angle, you take the square of both sides. So both sides, take the square of both of them, add them together. Does that sort of sound like another formula that we all kind of memorized and know well? Not quite. Something is equal to something squared plus something squared. Pythagorean theorem, right? Even look at this, it starts off like the Pythagorean theorem. A squared is equal to B squared plus C squared. Here, we're not saying that A is the hypotenuse. A is just a side that we don't know. You take the other two sides, square them, add them together, but we subtract 2 times both of those side lengths times the cos of the angle that we know. And that's how we get the other side squared. So to get the length of the other side, you just take the square root of that. Yes, Adrian?
So you must know the angle in between both sides.
You must know the angle, because if another angle is given, chances are you could just use the sine law, because then you have a side opposite an angle. So the only instance where we only know one piece of everything is where we have the angle in between the two known sides. So in that case, you have to use the sine law. Sorry, you have to use the cosine law because the sine law won't work. Okay, questions? That's basically cosine law in a nutshell. So let's go through an example. Calculate the length of B, round your answer to the nearest hundredth. So draw your triangle. Hopefully from between here to beginning of May, get so sick of drawing triangles. It's not even funny. So unknown side, angle opposite it, and the two other sides. That's sort of like the red flag in your head to say, I need to apply the cosine law. Everyone want to try to do this? Volunteers? Well, our unknown side. Gonna square it. It's equal to the other sides that we know. Does it matter which one's A and which one's C? No. So I can say this is A, this is C. So that makes this angle C, this angle A, and we know that this angle should be B already. Just so that my triangle is completely labeled. A squared, so B squared, A squared minus 2 times the two side lengths that I know, which is A and C, times the cos of the angle that I know, which is B.
Wait, what was the,
Why?
why'd you give us the two other formulas if we? Because that's the unknown.
The B
Oh.
is unknown.
Because B is unknown, like that's what I said, I don't like formulas because now you're tied to which
Yeah.
side is A, which side is B. It really doesn't matter. So in this case, I have put the label for you. It was B. If it was unlabeled, then you could choose whatever it is you like. So B squared is equal to A is 10 squared, C is 15 squared, minus 2 times 10 times 15 times the cos of 66. That was a bad looking 6. So B squared is equal to 100 plus 15 squared is 225 minus 2 times 10 times 15 times cos of 66, which is same as 300 times the cos of 66. 300 times the cos of 66. Calculators, pretty calculators.
122.02.
Thank you, 122.02. Again, I strongly encourage you, have your calculators, punch it in as we go along. That way you know you're punching it right in your calculator, getting the same answers that we're all getting. So here B squared is equal to 100 minus, so it's 125 minus 122, 118? No, 102.98. Is that right?
Wait, what?
Did I do math in my head right?
But it's 325
Yeah.
minus
Oh, it's 202.98.
Yeah.
Yes?
Isn't it
Yeah,
202.98?
202.98.
Yes.
It is. Because you have to add the first.
So 100 plus 225 minus 122.02 should give us 202.98. Want the square root of both sides because I just want B. So what's B equal to?
14.24.
14.24. Okay, so that's where we got down here.
Yeah.
So same question as we did before, except a lot less algebra, but just plug in the formula. Okay? Again, I would still prefer the sine law over this because this is still tricky. Type in your calculators, making sure you got the order of operations correct. Any questions on this? Question, Daniel?
Eventually go over the question that we did before.
At the very beginning?
Yeah, the really complicated one.
When you first.
Whenever you want, but like
Okay, we'll go back. Okay,
Now or?
in a bit. What's applying this? That was sort of understand where the formula comes from. You don't actually have to know it. It's great that you would. Because that, to me, that's where the math is fun. Math isn't fun in memorizing formulas and plugging it in. Ladies and gentlemen, this is all we're doing. Taking a formula, plug it in, numbers for those values, taking a calculator, plugging it in. Not very fun math. That's why I like the other stuff where does this stuff actually come from? To try to solve this problem by yourself, press pause now. Hopefully came up with a triangle that looked like this. So basically what we're needing to is solve for r. So if r squared is equal to s squared plus t squared minus 2st times the cos of r. So r squared is equal to s is 12.
Go ahead.
What is it that you don't understand?
Why would you use two formulas? If you I know you can do revert R and A and
That's why I debated whether this is depending how you label your triangles. They want to be complete and say, well, depending on how you label your triangle, you solve it for A, solve it for B, or you solve it for C. Like I said, I like to just memorize my formula by the concept. One side squared plus is equal to the other two sides squared. So if you don't want to remember the other two, that's fine, because they're really the same thing. Yes, Laura?
Is that a 2ST? 25?
This is s squared plus t squared plus minus 2st, 2 times s times t,
Yeah.
times the cos of r.
But it's in second.
I
So r squared is equal to 12 squared plus 9 squared minus 2 times 12 times 9 times the cos of 72. So somebody got r squared for me? Did this already?
R squared,
Yeah.
158.
158.25. So in order to get r, I take the square root of both sides. So what is r?
Figure's gonna hate.
Sorry? 12.68. So that's in meters. Okay. 12 squared is 144, plus 9 squared is 181, minus 2 times all this thing, which Katie said it was something. All this arithmetic here comes out to be 158.25, so I'm told. So to get r, I need to take the square root of that. How do I figure out the angles now? So get the angles. Now that we know an angle and the opposite side, right? We know big R and little r now. We go back to the sine law. So here's a tip. When you ask to solve a triangle, always try to use the sine law first, because it's the easiest. If you can't, because basically what you're given is the angle and the two sides beside it, then use the cosine law to figure out that other side. And now we know all three sides and one of the angles. We can go back to using the sine law to get the other two angles. Okay? I'm not going to demonstrate that. because it's just application to sine law again.
Is there a tangent law?
It's funny because the other class mentioned the same thing. I'm not aware of a tangent law. We could try to figure out something to do with tangent. But I tell you, if I do, it's going to be called the TAM law. It's not going to be a tangent law. It's going to be the TAM law. Or the TAM law.
And then you have like a mathematical law.
Here's the homework. Write it down.
It's probably good.